We are on page 26 today in your Unit 1A packet, and we are going to talk about factoring when we have 4 terms to our polynomial. So from here on out, our discussions on factoring are going to revolve around how many terms our polynomial has. Today, we're going to talk about 4 terms, and we're going to use a method called grouping. We'll also talk about how to factor polynomials with 2 terms and polynomials with 2 terms and polynomials with 3 terms. No matter what type of polynomial we're factoring, our first step to factor any polynomial is always to start by looking for a GCF, a greatest common factor. So is there something common to every term in my polynomial? If there is, I need to factor that out first and then factor based on the methods that I have. So again, today we're going to look at grouping, and that's our strategy for when we have 4 terms to our polynomial. So grouping means that we are going to break our polynomial into groups. So when I have 4 terms, we're going to split it into groups of 2, the first 2 terms and the last 2 terms. And that's sort of what we see here with those parentheses. So we're going to look at this and this. And within each group, we're going to look for a GCF. So in my first group, I can see I have a GCF of x squared. So what I'm going to do is factor out that GCF. So x squared is my GCF. If I factor it out, I would have x minus 3 left over. And then I'm going to do the same thing with my second group. I have a GCF here of 2, so I'm going to factor that out. Left over, when I factor out that GCF of 2, I have x minus 3. The terms that I have in parentheses should be the same. Anytime I factor by grouping, the stuff in parentheses should be the same. I want it to be the same because this actually now acts like a GCF. This is now a common factor for my whole problem. Each of these terms has an x minus 3, so I'm going to treat it like a GCF and factor out the x minus 3. When I factor out the x minus 3, I'm left with x squared plus 2. That's what's left over when I pull out my GCF there. So my entire factored expression would be x minus 3 times x squared plus 2. And remember, if you have the order of these factors reversed, that's fine. This could also be x squared plus 2 times x minus 3. That means the same thing, as long as you have both of these factors. So that's the strategy we're going to use for factoring for our 4-term polynomials on page 26. So remember, the first thing we want to do is check for a GCF. So I've got 6x squared plus 3x plus 4x plus 2. They don't all have an x. They're not all even. They're not all multiples of 3. So I have no GCF here. So I'm going to go ahead and split these up into my groups, first 2 terms and last 2 terms. The GCF for my first 2 terms would be 3x. When I factor out 3x, I'm left with 2x plus 3x. Factor out 3x would just leave me with 1. For my second group, my GCF here would be a positive 2. I want to make sure I include the sign. And when I factor out positive 2, I would be left with 2x plus 2 divided by 2 would be 1. Now notice the stuff in parentheses is the same. This is now my GCF for the entire expression. So I've got 2x plus 1, that's my common factor now. When I factor out 2x plus 1, I'm left with 3x plus 2. So there's my factored form. And then we'll come back and state the x-intercept on all of our problems at the very end. For my next example, same idea, start by looking for a GCF. For this problem, every term is divisible by 2. So I can factor out a GCF of 2. That would leave me with x cubed minus 3x squared plus x minus 3. Now that my GCF is factored out of my original problem, I'm going to split this into groups and use that grouping method. My GCF for the first group would be x squared. I can evenly divide both of these pieces by x squared. If I factor out x squared, that would leave me with x minus 3. For my second group, I actually don't see an obvious common factor here. They both don't have x. They're both not divisible by 3. So if I don't have an obvious GCF here, that means that my GCF is only 1. So I've got a GCF of positive 1 here. If I factor positive 1 out, I'm left with x minus 3. Now I can see my step in parentheses is the same. That's my new common factor that I'm going to pull out, x minus 3. And when I pull that out, I'm left with x squared plus 1. And then don't forget our GCF of 2 in front here. For our next example, we're going to start the same way by looking for a GCF. Look for a greatest common factor for all of those terms. They don't all have an x. They're not all divisible by 2 or any multiple of 2. So we've got no GCF here. So I'm going to go straight to breaking this up into my groups. And then I'm going to look for a GCF, that greatest common factor, for each of my groups. For my first group, I would have a GCF of x squared. When I factor out x squared, I'm left with x plus 4. For my second group, I've got a GCF of positive 2, and I would be left with x plus 4. Now that piece in parentheses is the same, so that is my new GCF for the entire problem, for the entire polynomial, and I'm left with x squared plus 2. X squared plus 2. There we go. Our last example on page 26, again, we're going to start by looking for a GCF. We don't have any factors that are common to every term in this polynomial. So we'll go ahead and split this up into our groups. And then we're looking for those common factors for each of our groups. For my first group, I have a common factor of x to the 4th, x to the 4th. That would leave me with 2x plus 3. For my second group, I have a GCF, a common factor of 3, positive 3. That would leave me with 2x plus 3. Again, my piece in parentheses is the same. If you ever pull out your GCF for a group and your stuff in parentheses is not the same, go back and double check that you actually pulled out your greatest common factor and not just a common factor. Since it is the same, I know that that's what I want to pull out as my GCF now. And then I'm left with x to the 4th plus 3. Now that I've factored each of these polynomials as much as we can for now, later on we'll talk about ways to factor some of these things that still have x squared or x to the 4th. We're going to leave them as they are for now. But now that I factored as much as I can for right now, I'm going to find any x-intercepts that I can see. So we talked about x-intercepts already. If I've got a number in front of x, remember you can set that factor equal to 0 and solve for x from there. So this would be -1/2 for one of my x-intercepts. Or you may be comfortable sort of using that kind of shortcut. We're going to change the sign and then divide by the coefficient. So I've got 2 x-intercepts I can see for that first example. In my second example, the only term that I'm going to pull an x-intercept from right now is the one where I've got just plain old x. We're going to leave this x squared term for right now. We'll talk about stuff like this a little bit later. But this guy would have an x-intercept of 3. Down here from our x, remember this would be like x to the 1st. From our x to the 1st factor, I would have an x-intercept of -4. And then from our last problem, again, if you want to set that equal to 0 and solve for x, that's fine. Or if you remember that we're going to change the sign and divide by the coefficient, we would get our x-intercept to be -2/3. So that's factoring using a grouping method. Remember, we always start by looking for a GCF. And then either after we pull out a GCF, or if there is no GCF, we're going to split our 4-term polynomial into groups of 2 terms, I should say, and then look for our GCF.